Alright, so we're going to go over this problem where a choir contains 15 boys, 15 girls, and 9 boys. And the choir master is randomly selecting 4 singers to be interviewed by a newspaper. So we want to find the probability that at least one boy is in the 4 singers selected. Uh, so, we could try to write out a bunch of stuff. I think the easiest way to do this is to go to make a tree diagram because it helps us organize our information really well. So imagine for the first pick, right? Like boy or girl, he's gonna pick the first person, right? So this would be, we'll choose boy here. The probability that the first pick is a boy is 9 out of 24, right? Because that's 9 boys out of 24 total. And down here, this is 15 out of 24, and that's that we get a girl, right? And then that's the first pick is boy or girl. The second pick, same idea, right? You can either pick a boy, a girl, right? So for this one, this is probability of a boy being picked, given that a boy has already been picked, right? So if I already picked a boy, now there's only 8 boys left, so this is going to be 8, and there's only 23 students left, right? Because we already picked one, so there's only 23 students. The probability to get a girl, given that a boy has already been picked, is 15, right? We haven't picked any girls, so there's still 15 girls, but there's only 23 students left, right? Same idea down here. Boy is going to be, what's the probability to pick a boy, given that I already picked a girl? Well, there's still 9 boys left in this class, but again, only 23 students. And then for the girl, we picked one girl already, right? So this is the probability I pick a girl, given that I already picked a girl. So there's only 14 girls left and 23 total students, right? And then we're picking a total of 4. So we need to go ahead and keep going with this and find the next one here. Hold on. Okay, so then we're going to keep going with this, and it may seem a little bit tedious to do all this, but it's really going to help you organize your information so you can see what's going on, right? Until you see it. And there is another way, but you have to be able to see this first before you can do that other way. So again, we're going to do boy, girl, and then, here we're going to have boy, girl. Here we're going to have boy, girl, and then here we're going to have boy, girl, right? And we're going to calculate all these probabilities. So again, this up here is what's the probability to pick a boy, given that I already picked 2 boys, right? So in this case, there's only 7 boys left, and there's only 22 students left to pick from, right? Because you already picked 2. Here, we haven't picked any girls yet, right? So there's still 15 girls, only 22 students left. Here, for this boy, we've picked 1 boy and 1 girl, and we're saying what's the probability I pick another boy, right? So there's 8 boys left in this one out of still 22 students, right? Because another girl got picked as well. Here we picked 1 girl, so there's 14 girls left out of 22 students. Down here, same idea, we picked a boy and a girl, therefore there are 8 boys out of 22 students. And here there are, you picked a girl, so there's 1 less girl, so 14 girls out of 22 students. Oh my. And then here, you picked 2 girls. What's the probability to pick a boy? You haven't picked a boy yet, so there's 9 boys, 22 total students. Here you picked 2 girls already, so there's only 13 girls left out of 22 students. Right, I'm going to go ahead and save some time on the video, and I'll just go to make the next one so you can see it. Okay, so here's the finished tree diagram, and you can start using this. You could use this to create this sample space if you wanted to, right? So for example, if you just follow these pathways, you can see all the possibilities. So one pathway is boy, 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 right? So that's one thing that's in the sample space is the occurrence boy, 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 right? The probability this happens would be equal to, so the probability of boy, 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 boy would equal 9 over 24 times 8 over 23 times 7 over 22 times 6 over 21, right? And that would tell you the probability of boy, 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 boy. And then, you could do that for the rest of these things as well. What you should do is you should ask yourself, okay, well, does probability, is boy, 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 does that meet this criteria of what we want here, right? Is there at least one boy in the four singers? Yes, there's 4 boys, right? So this one would be one of the outcomes that we're looking for, right? We could then look at the next one, which is boy, 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 and then girl. And that also is in this thing that we want, right? The event that we want, which is, oh, there's at least one boy, right? So you could find all the ones that we want. And maybe then you start noticing, well, okay, boy, 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 girl, like anyone, maybe you then realize anyone along this path is going to have at least one boy in it because the first one is a boy, right? So all of those ones count. And then you go down here and you say, okay, well, girl, as soon as you get here, all of these ones also have at least one boy because they have this boy. And then when you get here, like, you could go girl, girl, boy. As soon as you get to that boy, the rest are going to have a boy in them. So the only way to not have at least one boy is to go girl, 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 right? So at least one boy is the same thing as, right? So you could say the probability of at least one boy, that's the same thing as the probability of all. So it's the same thing as basically 1 minus the probability of all girls, right? Because all girls is the only one that doesn't have at least boys. So if I could just figure out, well, what's the probability that they're all girls, then I could just subtract that from 1 because the rest is going to be at least one boy, right? So the way we're going to figure out probability of all girls is we're just going to multiply 15 over 24 times 14 over 23 times 13 over 22, so on and so forth, right? So we're going to do, and 15, we're going to go and do the top first times 14, and there's a nice little formula for this as well, but I don't think we get into that really in this course, so we're just going to do it this way instead of learning a whole new thing. Times 12, right? That takes care of the numerators, and then we're going to take that numerator and we're going to divide by 24 times 23 times 22 times 21. And that's going to give us this 12.8 chance, right? So this is, again, remember, this is what we just calculated is a probability that's all girls, right? So the probability of all girls is about 12.8% chance. Again, we're going to keep all our numbers until we get to the end. If I want to know the probability that there's at least one boy, I'm just going to subtract the probability that there's all girls from 1, right? So I'm just going to go ahead and take this number from up there, and that's going to give us the probability that there's at least one boy is 0.872 if you round into 3 significant figures, right? So that's, the whole tree took forever, right? But once you have to do the tree in order to see the pattern that is, at least one of this basically means 1 minus, all girls. And so hopefully that helps.